So the very initial concept after reflection, we have reached to the another part that is called as a refraction. Refraction, you are aware about such type of word. What is refraction? So in a 10th, you are aware about a refractive index. So first of all, we will discuss about it. So in a refraction category, very first thing you have to learn is called as a refractive index. Now refractive index is what? So you are putting such type of symbol n or mu. So initially we will discuss about it, then we will move to the formula. That is why that is called as a n is called as a refractive index. It is called as a ratio of two velocities. C, that is called as a velocity of light in vacuum. And then after that we have a V, that is called as a velocity of light in media. That is a purely a reference thing. That is called as a comparison of velocities. If my velocity of light is passing in the vacuum, you are aware about its value, that is 3 cross 10 to the power 8. And velocity of a light in the media, that might be anything. And we are comparing both those things. And that is called as our velocity and light in a vacuum and a light in a media, that is called as a refractive index. So let's say you are saying that your refractive index of air is 1. It is not a thing to mug up, it is the thing to understand. The velocity of light is a 3 cross 10 to the power 8. Same is the course of velocity of a media, light in a media. If it is also 3 cross 10 to the power 8, then you can say that it is called as a 1. If my velocity somehow is lesser than this one or higher than this one, then accordingly I can say my refractive index is 1.5. So such is the case where you can say that my velocity of light is lesser, because velocity of light is lesser in the media. Let's say initially I have placed 3 cross 10 to the power 8. I am assuming that velocity of light in a vacuum is a very higher one compared to all those media. Till today, it is the highest one. So I'm putting that my velocity of light in a media is only lesser, and that is 2 cross 10 to the power automatically 8. So my refractive index is 1.5. So whenever your light is passing in a thicker medium, then your velocity is gradually decreasing. So both are, you can say, correlated, vice versa thing. So this is how refractive index is working. One more thing I want to share with you is that it's a refractive index is a unit. So it's a unit is called as a unitless quantity. It is not holding any type of units, so that is why it is called as a unitless. If it is unitless, it does not contain any type of dimensional configuration. So it is unitless quantity, and again it is dimensional less quantity. So there would be no dimensional configuration. Now, one more thing you can say that in physics, throughout your journey till ninth chapter, there are previous things where you can find it out there is no unit at all. Starting from the chapter number 1, you have a relative permittivity, then you have relative permeability, then susceptibility. Here you have magnification as well. It is also unitless because it is comparison of position of the object and image, and it is also same call as a height of the object and image. Both contains the same unit, so it is again unitless quantity. Apart with that, that is called as a refractive index. It is itself unitless quantity. So it has been continuously observed that there might be single or two times where they have asked that, okay, any single quantity which I have mentioned over here contains no units. So it is itself unitless quantities. These are the unitless quantities. You may have also learned chapter number 14, semiconductor. In semiconductor, there are so many units which are also unitless. It is called as our gain, power gain, voltage gain, and current gain. So these are the things, minor things where you have to just deal with. Now, after refractive index, that is called as a relative refractive index. So it is denoted by the symbol n or mu. Now, relative refractive index is what? A relative refractive index. Why there is a need? Because itself refractive index itself a comparison. itself a relative thing. Relative का भी relative. It is called as a double time relation, a double time comparison. Yes, you can compare your refractive index with one more quantity. That is why it is called as a relative refractive index. So relative refractive index is what? Let's say you are aware about refraction. So refraction will only happen when there is a media, single media, or it is having another media connected. If there is a single media, then we have a reflection. If you have a two or more than two media, then it is called as a refraction. So there is a possibility then where your light can have possibly availability of second media, and that is why refraction may occur. And refraction, then your light is experiencing two different type of media, first and second. At that time there is no need to, you can say, that comparison, because ideally we are taking air as a normal media, it is having only a value 1. But yes, again you can compare it with the initial media. So let's say I'm giving you one simple example. First of all, let's say I have a such type of box, and such type of box I am putting that my ray which is passing from very single media, means from the air, and it is entering into the another media. Let's say I'm drawing a normal. So first of all, let's say I am applying my ray of light onto the point P. Let's say I'm drawing a normal. I have drawn a normal. I'm naming it as a N and N dash. It is my normal. And on that verge, means at a point P, which has been separating two these different units. So let's say this is my second media and this is my first media. It is having refractive indexes. So I'm mentioning it. N1 is called as a refractive index of first medium, and then N2 is called as a refractive index of second medium. Now I am putting a ray of light. So let's say my ray of light has been applied at this point P. As per our notation, it should pass straightway. So it should pass like this way. And again, it should pass in a from second media and coming out in the first media in a straight fashion. But whenever it is changing its refractive index, we will discuss about it at a later end of this chapter or a later part of this lecture. So it should pass in a straight fashion. But its nature is suggesting us that whenever our ray is passing from very rarer medium, means a thinner medium, to thicker medium, it is called as a denser medium, the ray is coming near to normal. So what happened then? Rather than going straight forward fashion, it is changing its course, and now it is like this one. Again, if I am drawing another normal, which will be our helpful position, so I am drawing another normal and putting that point Q. So this is on the point of second to third or outside medium. Again, my ray must pass out or come out in a straight fashion. But whenever such type of path would be there, my ray, whenever it is coming out from the denser to rarer medium, it is getting away from the normal. So I am drawing now again a normal thing. So let's say my ray is passing in a such a fashion, it is going away. So you can just compare that path, trajectory. So I'm putting those path or trajectory in front of you. Let's say my ray initially starting its journey, that is called as the incident ray. It is called as a AB. It should pass in a straight fashion like a dotted path in a black line, but it is not following that path as per its nature, because it is passing from the rarer to denser. So it is coming near to normal. So now my new ray, it's a new path is busy. Again, it should pass in a straight fashion like a dotted path, but it is not following so, because its nature is called as a, it is coming out from the denser to rarer medium, so it is getting away from the normal. So it is holding another path that is called as a CD path. So just imagine initially AB, if it has been not, if there not be another media N2, if N2 would not be there, then there is no chance of refraction. But N2 is there, and again N2 is playing its role, and you can see that AB path and last dotted path is something different path which we have predicted, and AB path and let's say CD path, which is something another different path. So where our role of relative refractive index is been observed. So relative refractive index is like this one. Now to put these things, we will just follow another rule that is called as a Snell's rule. But before going further, I will put that relative refractive index. So right now it's a starting its a journey. My ray of AB is a starting its a journey from the refractive index media N1 and going to the another media that is called as the N2. So it is starting its a journey. So it has been always placed in the denominator and it is ending at the second media. So you can place it like this one. It is a starting its a journey from the first media and ending at the second one. So it is written as a N21. So whichever refractive index will be placed in a denominator, it is indicating that my ray has started its journey from that media only. Now, for the second to third one, from the second media to third one, my ray is coming outside. So I can place that it is starting its journey from the second media and ending at the first media. So I will place that it is called as a N12. Always consider that such type of N21 multiply by N12 is always 1. Just multiply it and you can observe that it is completely one thing. It is called as a unity. So this is the very primitive thing. You have to always remember such type of thing. So this is N21 and N12 is called as a one MCQ they have asked in the previous exams as well. So this is the thing to be remembered. One more thing I want to add that sometimes some people is mentioning that it is a N14 or 41. So you can say that it is a starting, it is a journey and reaching to the fourth media. Be careful. Yes, in mathematical notation, we can mention that N41 that it has started as a journey from the first media and it has ended at the fourth media. You cannot say that it has a jump or skipped second and third media because in a refractive index, skipping is not allowed. If there is a skipping, then refractive index concept is not allowed. So you have to just understand that it has started its journey from the second media, ended at a second one, again started from the second media, ended at the third one, again started from the third media, ended at the fourth one, and by such type of calculation, it has reached out, or final media is the fourth one, and initial media was the first one. If in a figure I want to mention this one, then I can draw like this one. So let's say I'm drawing such type of figure. Let's say this is the second media, this one is the third media. Let's say I'm drawing in another color, so it will be quite easy for you to understand. And then fourth media. Okay. Uh, let's say my journey is starting from the first media, second media, third media, and fourth media. I am not going to put my ray again coming out from the fourth to the first one. क्योंकि यहाँ से N4 से वापस बाहर आएगा तो N1 बोल सकते हैं. But मुझे ऐसा दिखाना नहीं. तो मैं क्या बोल सकता हूँ कि it has started as a journey from the first. So that was the journey of our relative refractive index. Now after relative refractive index, we want to put it's another equation, and that equation is called as what? And that equation is our Snell's law. So let's say I am putting that Snell's law. Now, what is the meaning of a Snell's law? First of all, Snell has suggested that whenever refractive index will be there, it is holding such type of formula that is called as a n into sine theta is called as a constant thing. So n is a refractive index and sine theta is called as our incident angle or angle which is with the media as well. So let's understand this part. Let's say this is the first media I am available to you and putting in front of you, and this is my normal. I'm drawing a ray. which is incident ray. So let's say this is my incident ray. It has made an angle with my normal line, and that is called as the incident angle I. This is my normal N1 and N2 line. You are aware that it should pass from a normal way or a direct way in a straight fashion. So I'm putting at a projected ray line, but it is not passing in a projected fashion. It is somehow deviated because it is passing from the denser to rarer. I will mention this one, so it would be quite easy for you to understand. So this is N1 and this is N2. I am mentioning this fact so you can understand that okay, N2 is higher than an N1, means refractive index of the second medium is higher than refractive index of the first media. That is why my ray is attracted towards. It is not attracted, means it is somehow deviated, or its a path is like this one. So it is coming near to the normal line. So near to the normal line is a proper word. So N1 is a rarer, means you can say thinner, and N2 is a thicker, it is called as a denser medium. So Snell has suggested that N multiplied by sin theta is constant. So let's say I am following the same formula and I am mentioning that initially my media is the first one, and in that media my angle is a sine I. So my angle is called as I is called as the incident angle. So N1 sine I is considered as a constant part. Same is the course in the second media, N2 sine R, that is again constant. So I'm comparing both. So I can have N1 sine I is equals to N2 sine R. This is called as our Snell's equation for the refraction, where you can say that my I is called as the incident angle and R is called as a refraction angle. So incident angle and R is called as a refraction angle. So this is how it has been placed as I and R. Now there is one limitation of Snell's law. Whenever two or more than two mediums are there, then what you will do? Here you have placed that. So you can say that it is at the same time applicable to the two media, but whenever you have a two or more than two media, so you can compare first and second one, then second and third one, then third and fourth one, like that. Yes, you can use, if you are aware about its angle, then you can place that first is compared with the fourth medium as well. It is also allowed. So there is no limitation like that. Okay, you cannot use for the infinite mediums. Even though you have infinite mediums, you can also use a Snell's law. So Snell's law is in front of you, N1 sine I equals to N2 sine R. So first of all, you can say that, or you can remember like that, denser to rarer or rarer to denser. So let's say I'm putting this thing. So if denser to rarer, it is going away from it, going away from normal. You can place it with the help of angle as well. एंगल से भी प्लेस कर सकते हैं, और वाइसा वर्सा बोल सकते हैं कि भाई ये रेयरर से डेंसर में जा रहा है, तो ये नॉर्मल से नियर आ रहा है. तो यू हैव टू रिमेंबर दिस फैक्ट. So there are two things we have learned in our Snell's law. Now, Snell's law is applicable to the refraction only. It is not used for the any type of surface. Against the reflective surface, so it is not applied because it's a starting is a, or pioneer or basic thing is that whenever you are having more two or more than two media, अगर it is in the first media, तो रिफ्रैक्टिव इंडेक्स अगर वन है नहीं है कुछ भी है चलेगा. अगर मेरा रे है जो एन टू मीडियम में पड़ा हुआ है और एन टू में ही उसको अप्लाई करना है, तो देयर इज नो नीड टू पुट सच टाइप ऑफ थिंग. तो रिफ्लेक्शन की जरूरत ही नहीं है क्योंकि एन टू ही इट इज बिहेविंग एज अ रिफ्लेक्शन मीडिया, रिफ्लेक्टिव मीडिया. तो इट इज एप्लीकेबल टू दी only pioneer or basic things. It is been used when you have a two or more than two media. तो उसके लिए ये वाला फॉर्मूला जो है you have to remember it. After this fact, I want to add one more thing, and that is called as what are the advantages of it, or somehow disadvantages of it, or where you can observe it? Advantages or occurrence? So very first thing I want to mention over here is that you may have heard that word, and that is called as total internal refraction. एक होता है रिफ्लेक्शन, और यहाँ पर मैं बोल रहा हूँ टोटल इंटरनल रिफ्लेक्शन. इट इज अ occurrence due to the refraction phenomenon. So this is how total internal reflection is also dependent on refraction. So we will discuss about it. Some of the natural processes or natural events, you can say that, where you can observe this thing. So natural events, you can say that whenever you have learned that whenever you are watching or viewing a pencil dipped into the water, you can say it is somehow bent. It is natural event. When a fish, or whenever you have dipped into the water and you are trying to view something which is outside from your water pond or water swimming pool, then it will look like that that object which is when viewing from you from the outside, it is look like a getting away from it. It means that you are swimming into the water and you are trying to view something which is outside of a water. It will look like it is near, it is away from you, but actually it is near to you. So such type of events or natural occurrences or natural processes are only because of the refraction. Now, one more thing, it is called as a total internal reflection. In total internal reflection, we will discuss about it in a later lecture, but I want to mention these facts. There are two things we will discuss about it in the total internal reflection. One is called as a mirage, or some people say that mirage. That is called as a mirage. In a Gujarati language, you are saying that mrugjad, or you can say marichika, and you can say that it is illusion, purely illusion. Whenever you are moving on a highway and it has looked like slippery surface or water or fluid is floated, it is a only incidence of a marriage. Another thing is called as our diamonds are shining. So marriage and our diamonds are shining. These are the two ideal examples of total internal reflection. So we will discuss about it in a later part. So this is how you can use our refraction. So refraction, reflection ka primary difference sometimes it is been asked. So you must to aware about that reflection does not need any type of media as well. It is happening only in a single media. Refraction is possible in a two or more than two media. Reflection requires only incident angle and reflection angle is equal. In a refraction, incident and refraction angle both are different. In a reflection, we have a Gauss's equation. In a refraction, we have a Snell equation. So these are the primitive differences between the reflection and refraction.